So in last classes we discussed about relations and functions. Now the next topic of relations and functions is the binary operations. Binary operations. This is a type of function. This is a type of function. What type of function? Let us see. If we have natural number to natural number tends to natural number. Let us see. What is the binary operation from an example? Natural number to natural number tends to natural number for the sum a plus b is the function. Let us see. Can you say that the sum of two natural numbers is also natural number? Sum of two natural number must be the natural number? Yes. So a plus b is equal to what? The natural number. If you say a multiply b, means a and b are what? A and b. A belongs to first set and b belongs to the second set. And the product must be the right hand side. So a multiply b, a minus b, we can take ab plus b. We can take these type of function in the binary operation, and generally the binary operations is denoted by star or not or some other symbols. These are the symbols for binary operation. Generally, binary operation denoted by star. Let us see. You can say that in this each star a binary operation for natural number to natural number. Is star a binary operation for natural number to natural number? Yes. Yes. Is star binary operation for natural number to natural number? No. Because difference of two natural number may or may not be a natural number. So this is not a binary operation in natural number to natural number tends to natural number. But if we have integers, by integers tend to integers, then star a star b is equal to a minus b. Is it binary? Yes. Now it is a binary operation. Why? Because these two a and b must be the integers and tends to another integer. So here a and b are the integers and a minus b is also an integer. A minus b must be an integer, right? So this is the binary operation. This is a kind of function, but this is not a function. This is a binary operation and it is denoted by a star. You can say that star integers, two integers, tend to integers. And let us see, the question is star binary for a star b is equal to ab. Is a star binary in this? The question is what? The question is a star b. A star b means what? Integers and integers, integers and integers, and this must be integers. So there are a and b are two integers. Is product of two integers is an integer? Yes. The product of two integers always integer. So we can say that star is a binary operation. Yes, star is a binary operation. But the question is star natural number to natural number tends to the natural number, and the question is star binary for a star b equal to a by b? No. This is not binary. This is not binary. Why? Because here natural number by natural number, two natural numbers. So a and b are the natural number, and the resultant must be the natural number. Then star be the binary. Here a star b is the product, the division of two natural number cannot be natural number. It may be natural number sometime, but generally it is not a natural number. If we have to consider a 5 and we consider b as 3, so 5 star 3, capital 5 by 3. This is not a natural number. The resultant is not a natural number, so we can say that this is not a binary operation. The very important question for 1 mark is star binary. That depends question. You have to observe these things. Either it is integers to integers, or it is natural number to natural number, or you can say that real number to real number, complex number to complex number, or some other thing. So we can say that in the case of natural number, star natural number to natural number tends to natural number, we can say that addition and multiplication is binary, but subtraction and division are not binary. These are not binary in the case of natural number to natural number. Why? Because the sum and the product of two natural numbers again the natural number, but difference and division of two natural numbers may not be natural number. Right? In the case of real number, these all four are binary operations. In the case of real number, the question is star real number by real number tends to real number, then addition, subtraction, multiplication, division, all are the binary operation in that case. Right? So this is very important question for 1 mark. Is star binary operation? Let us see from some example. The question is, check whether the following are binary or not. Check whether the following are binary or not. Question number 1. Question is, on Z plus define star by A star B is equal to A minus B. Is star binary? What do you mean by Z plus? This Z plus can be written as Z plus by Z plus, or Z plus star Z plus tends to Z plus. Z plus means what? Positivity. So if we have to consider these two are positive integers, can we say that A minus B is also positive integer? No. If you consider A is a positive integer 3 and B is a positive integer 5, but A 3 star 5 can be 3 minus 5, that is minus 2, that is not positive integers. So star is not binary here, not binary. But the question is, if on Q define star by A star B equal to A minus 1 divided by B plus 1, right? Is star 1, what do you mean by Q? Rational number, right? A star B equal to A minus 1 by B plus 1. So we have to consider two rational numbers here. So a rational number minus 1 by a rational number plus 1 is resultant rational number? Not sure. Not sure. Why? Because if we consider B as minus 1, that cannot be a rational number because that is not defined. The denominator 0. Here Q is not rational number, so Q star Q tends to Q. So this is not a binary. Why? Due to here. Right? Now, if on Z plus define star by A star B equal to mod A minus B, is star binary in this? Yes. Yes. Now star binary because Z plus, if you consider A and B as two positive integers, then modulus of A minus B must be the positive integer. If we consider the two positive integers in the place of A star B, so this function must be the positive integer because this is a modulus function. And you know modulus, the value of modulus function always positive. So therefore, this is the binary operation. Yeah, these are the binary operations. Now by this way we can solve, we can find the binary operation, or we can check the star is either binary or not. Right? You can check every star either binary or not. Right? Now we have some very important question for 1 mark that previously asked in the CBSE board, that is the binary operation star real number by real number tends to real number is defined as A star B is equal to A plus B. Then find 2 star 3 star 4. 2 star 3 star 4, right? The question is, the binary operation real number to real number tends to real number is defined as A star B equal to 2A plus B. Find 2 star 3 whole star 4. Star is just a type of function. It varies question to question. Star is not a constant term, not a constant value. A star B may be A plus B. A star B can be written as LCM of AB. A star B can be written as 2A plus B. A star B can be written as HCF of AB. A star B can be any mathematical relation between A and B. Any mathematical relation in A and B. That is called A star B only. Star is just a symbol for the binary operation. Right? So here we have to find 2 star 3 star 4. So this is the definition of star in this question. In each and every question, the star has some different function, some different meaning, some different relation between A and B. So now in this question we have to find 2 star 3 whole star 4. So first we have to find this, solve this bracket. So A star B equal to 2A plus B. So 2 star 3 can be written 2 into 2 plus 3 star 4, right? A star B 2A plus B. So it is 2 into 2 plus 3. It is 4 plus 3 7. Now 7 star 4. Now again we have to apply same A star B 2A plus B. So we can write 2 multiplied 7 plus 4, right? A that is 7 and B that is 4. We can put here 7 and 4. Now you can say that this is 7 to the 14 plus 4 18. This is the answer. 2 star 3 whole star 4. This is the answer. By this we can find the stars. That depends question can be any relation between, any mathematical relation between A and B. In each and every question we have different meaning of the star. If we have a question, the binary operation star real number to real number is defined as A star B is equal to LCM of AB. Then find 3 star 5. Very simple question. So 3 star 5, that is what? According to this question, the meaning of A star, what is the relation between A star B in this question? LCM of AB. So 3 star 5 can be written LCM of 3 5. And you know LCM of 3 5 what? 15. Very simple. This is the star. By this way we can solve the question related to 1 mark. We can find the value of star. Right? One more very important question, that is, consider the binary operation. We consider a binary operation on the set 1, 2, 3, 4, 5, right? Defined by A, B. This is minimum of A and B. Write the operation table. Write the operation table of this operation. Write the operation table of this operation. Very simple question is it. Operation table, right? So the question is here, not star is not the symbol. Symbol different here. This can also be the symbol. Here symbol is this one, and the meaning of this symbol is minimum of A or B. Minimum of A or B. Means if you have to find 1, 2, that is 1, 2, 5, that is 2. That is called the minimum. And the table, we have to draw a table in which we have the numbers 1, 2, 3, 4, 5. Right? Either column wise or row wise, again same thing, 1, 2, 3, 4 and 5. We have to draw a table like this. And here we have to write this symbol. Now do you know A, 1 and 1? What is the minimum of 1 and 1? This is 1. What is the minimum of 1 and 2? That is 1. Minimum of 1 and 3? 1, 1, 1. Minimum of 2 and 1? 1. Minimum of 2 and 2? 2. Minimum of 2 and 3? 2. Minimum of 2 and 4? 2 and 2. By this way you can complete the table. Right? Minimum of 3 and 1? 1. Minimum of 3 and 2? 2. 3 and 3? 3. 3 and 3. Minimum of 4 and 1? 1. 2, 3, 4, 4. 5 and 1? 1, 2, 3, 4, 5. Yeah. This is the table. With the help of this table, we can find either 2, 5, 1, 2, 4, 5. We can find each and every term. This is a very simple question. By this way, we can draw the table for any binary operation. Like if we have the binary operation A star B equal to ratio of AB and it belongs to the set 1 to 5. Let us see. It belongs to set 1 to 5. So in that case, we have to write star here and LCM of 1 and 1, LCM of 1 and 2 here, LCM of 1 and 3 here we can write, right? By this way we can draw the table for if we have some limited element in the set, then we can draw the table. If we have unlimited element in this real number to real number, we cannot draw the table for this. We can draw the table for the set containing the finite limited number of elements. That means finite set. In the case of infinite set, that is real number, natural number, we cannot draw this type of table, right? So this is the basic concept of the binary operation. Now we have to discuss some rules which is applicable in the binary operation or not. Let us see. First one, the binary operation is different in different questions. So, first we have to discuss commutative law. Commutative law. In some question, the question will be, check the commutative law is applicable in this binary operation or not. Depend on question, what is the binary operation? Either A star B equal to A plus B, A star B equal to A minus B, A star B equal to A to the power B, A star B equal to 2A minus B, any relation that given in the question. So what do you mean by commutative law? If A star B is equal to B star A, if both are equal, then we can say that commutative law is applicable in that case. If A star B is equal to B star A, this commutative law is applicable. Second, associative law. This is also called associativity. A star B star C is equal to A star B star C. This is called associative law. A star B whole star C is equal to A star B star C. This is called associative law. Now, distributive law. Distributive law. For the distributive law, we must need two symbols. Let us consider these are the symbols star and naught. So we can say that A naught B star C. This is the boundary of not over star. Boundary of not over star. This can be written A naught B star A naught C. Dependent question. There must be two binary operations given for the application of the distributive law. Now these are very important: commutative law, associative law and distributive law. We need to solve the question related to this, and this is very important question for 4 marks. Let us consider the question is check the commutativity and associativity. Right? Check the commutativity and associativity. First question is A star B is equal to AB by 3. Check the commutativity and associativity is A star B equal to AB by 3. This is the binary operation. So, first of all, we have to check about the commutativity. For the commutativity, A star B must be equal to B star A. So here A star B is already given, that is AB by 3. What do we mean by B star A? B star A can be written BA by 3, right? AB by 3 is equal to BA by 3. Why? Because commutativity is applicable in the multiplication. AB by 3 must be equal to BA by 3 for any real number. So therefore, A star B is equal to B star A. So therefore, commutative law is applicable in this. Commutative law applicable in this. Second one, we have to check the associativity. How to check this one? We have to find A star B star C, and secondly we have to find A star B star C. A star B AB by 3, we can write it as AB by 3 star C. What do we mean by A star B? The product of both A and B divided by 3. The product of both A and B divided by 3. AB by 3 multiplied C with the product by 3. It can be written as ABC by 9. Now we have to find A star B star C. So A star, we have to solve the bracket first. It can be written as BC by 3. Right? Now we have to find A star BC by 3. Product of both and divided by 3. We can write it as A multiplied BC by 3 by 3. It can be written as ABC by 9. Yes, both are equal. Here we can say that A star B whole star C is equal to A star B star C. So therefore, associativity also applicable. Associative law is also applicable. So here commutative law is applicable as well as associative law is also applicable in this, right? Commutative law and associative law is a very simple concept. You already learned in class 5 or 6 about commutative law and associative law. The second part of this question is check commutativity and associativity. The second part of this question is star on R, real number, defined by A star B is equal to A plus B minus 7. If it is not given in the question A star B, whether it is in the form of natural number or real number, integer, so it must be the real number. In this case, A and B both must be the real number because it is not given in the question. But in this case, it is already given a star on real number, so A and B both must be the real number. In this case, first we have to check the commutative law. Commutativity. How can we check A star B must be equal to B star? Here A star B is equal to A plus B minus 7. And what do you mean by B star A? B star A is B plus A minus 7. If both are equal, A plus B minus 7, B plus A minus 1, yes. So therefore A star B is equal to B star A. And if A star B is equal to B star A, we can say that commutative law is applicable in this. Now second one is associativity. Associativity. Let us see how to find associativity in this. First we have to find A star, B star C, and then we have to find A star, B star C. Both must be equal, then we can say that associative law is applicable in this. Now, what do you mean by A star B? Sum minus 7. So first we have to solve the bracket. It can be written A plus B minus 7 star C. Now what do you mean by the binary operation A star B? Sum of both the real number minus 7. Sum of both the real number minus 7. A plus B minus 7 plus C minus 7. Sum of both the real numbers, sum A plus B and minus 7. You can write it as A plus B plus C minus 14. Now we need to solve this one. A star. What do you mean by B star C? Sum of both minus 7. Sum of both B and C minus, sum of both and minus 7. So A plus B plus C minus 7 minus 7. We can written A plus B plus C minus 14. Now these are equal. So associative law is also applicable in this. In the case of real numbers. Very simple questions. Now we have to check the associativity and commutativity. It will be very simple question. You can check the commutativity and associativity in the question. Let us see for the distributive law. Consider the binary operations. Consider the binary operations star real number to real number 10 to real number and not real number to real number 10 to real number, right? Defined as A star B is equal to mod A minus B and A not B is equal to A for all A, B belong to real number, right? Then prove that star is commutative but not associative. Not is associative but not commutative. Further prove that star is distributive over naught and thus not distributive over star. So these are some questions in this. Now we have two binary operations in this question, star and not. This is very important question asked in 2012 CBSE board. Now the question A star B is the modulus function A minus B. A not B is equal to A, means first element, right? So now, first case 1, star. First we have to check for star. So what do you mean by A star B? Mod A minus B. What do you mean by B star A? Mod B minus A. Do you know mod A minus B is equal to mod B minus A? Because in the modulus function both the values are same. Commutative law is applicable in the modulus function. You know mod 3 minus 2 is equal to mod 2 minus 3. Mod 1 by 2 minus 1 is equal to mod 1 minus 1 by 2. It's very simple. So therefore A star B is equal to B star A. Commutative law is applicable. Now for associative law. This is commutativity. For associative law, A star B star C can be written as mod A minus B star C. Now this can be written as mod of mod A minus B minus C, right? This is a positive value, minus C. And to find A star B star C, it can be written as mod, A star mod B minus C. And what is the meaning of A star mod B minus C? A minus B minus C mod. Is both equal? No. These cannot be equal. You can take any example and see these cannot be equal. Mod A minus B minus C of mod, it cannot be equal to A minus B mod B minus C of mod. You can take an example of real number and see that these two are not equal. So therefore, A star B star C is not equal to A star B star C. So, commutative law is applicable in the star and associative law is not applicable in the star. Now, for not, case 2. Case 2 is what? Not. Not means what? A not be equal to A, the first element. A not be equal to the first element only. So, A not B can be written as A and B not A can be written as B. Is A and B equal? No. So, therefore, A not B is not equal to B not A. Because A not B equal to A and B not A equal to B. So, A not B not equal to B minus A, B not A. So, commutative law is not applicable. Now, we have to check the associativity A not B not C and then A not B not C. A not B means A not C, that is A. A not B A, right? If you have to find not in this, means the first element is the answer. So A not B can be written A and A not C can be written A. A not B not C B and A not B A. Both are equal. So therefore A not B not C is equal to A not B not C. These are equal. The associative law is applicable but commutative not applicable. We need to put this thing only. Star is commutative but not associative, commutative but not associative, associative but not commutative, yes, associative but not commutative. Very simple. Now we prove first and second part. Now third part is about distributive law. Prove that star is distributive over naught. Star is distributive over naught. Means in third case, case 3, third question, third part. We have to prove A star B naught C. A star over naught. Means A star B naught C must be equal to A star B not A star C. If both equal, with both sides equal, left hand side and right hand side, so we can say that distributive law is applicable with star over naught. So in this case we can write left hand side at A star. First we have to find the bracket. B naught C means B, first element. And then A star B how much? Mod A minus B. Now A star B, that is mod A minus B, right? Not A star C, mod A minus C. What do you mean by not? If you find not of these two elements, the first element is the answer. So A minus B, not A minus C, mod A minus B. Now both sides equal. So therefore, star is distributive over naught. The fourth part is not is distributive over star. Not is distributive over star, fourth case. So we have to find A naught B star C is equal to A naught B star A naught C. Is both sides equal? Let us see. A naught mod B minus C and A naught mod B minus C is A. Left hand side A, right side A naught B A star A naught C is A. So it becomes mod A minus A, that is 0. A is equal to 0, not possible, not equal. So not is not distributive over star. Not is not distributive over star, but star is distributive over naught. Right? So by this way we can prove the question related to commutativity, associativity and distributivity, right? We can solve the question related to commutative law, associative law as well as distributive law. This is the second part of the binary operation. Now the third and important part of the binary operation, that is identity element and the inverse element. Identity element and the inverse element. Let us see how to find identity and the inverse element. Let us see first one is identity element. Identity element of the binary operation. How to find the identity element? Let us see. We have to find identity element. So the formula to find the identity element is A star E is equal to A is equal to E star A. Then E is an identity element. This is also a very important question for 1 mark. If A star E is equal to E star A, means commutative law is applicable and thus must be equal to A. So in this case, the value of E is called the identity element. The value of E is called the identity element, right? Now let us see from an example. Find the identity element for A star B equal to AB by 7. Find the identity element of the star where A star B equal to AB by 7. Let us see from definition A star E. E must be equal to A, and also E star A is also equal to A. Let us see. Do you know A star B equal to AB by 7? So A star E can be written AE by 7. This is equal to A. Any doubt in this? No. So if you cancel A with A, E can be written as 7. E star A, if A star be AB by 7, E star A can be written EA by 7 is equal to A. After cross multiplying, you get E equal to 7. This is the identity element in this question. 7 is the identity element in this question. So by this way, you can find the question related to identity element if the binary operations are different. Here binary operation is what A star B equal to AB by 7. Binary operation may be different. A star B equal to A minus B, A star B equal to 2A plus B, A star B equal to A plus B minus C minus 2. For any binary operation, you can find the identity element by this formula. When A star E is equal to E star A equal to A, then E is an identity element. By this way, we can find the identity element. Now the second part is inverse element. Inverse element. How can we say that inverse exists in the binary operation? Let us see. It's very simple. If A star B is equal to E is equal to B star A, then B is inverse of A, or A is inverse of B. Very simple. What do we mean by E here? E is the identity element. So to find the inverse element, first you need to find the identity element. And after finding the identity element, you can write A star B is equal to that identity element. The value of D must be the inverse of the A. And if A star B is equal to E and B star A is equal to E, then only we can say that the binary operation is invertible. If the binary operation is invertible, then only we can find the inverse element. Right? Now let us see some question related to this. If the binary operation, star on the set Z is defined by A star B is equal to A plus B minus 5. Find the identity element. Find the identity element with respect to star. Find the identity element with respect to star. So we have to find identity element here. What is the definition of identity element? A star E is equal to A and E star A is equal to A. Now, here the definition of star is A plus E minus 5 is sum of these elements minus 5. So A plus E minus 5 is equal to A. A is cancelled with E can be written as 5. No, it can also be written E plus A minus 5 equal to A. So therefore E equal to 5. Very simple. E equal to 5 in both the cases. So this is the identity element. E is equal to 5. E is equal to 5 the identity element. E is equal to 5 the identity element for this, right? So by this we can find the question related to identity element and question related to inverse element. Very simple. Now you learned the concept of binary operation, commutative law, associative law, distributive law, and question related to identity and inverse element. Now we need to discuss one more question. And the question is let A is equal to natural number by natural number and star be a binary operation on A defined by an order pair AB star CD is equal to AD plus BC comma BD. Then prove that first one star is commutative on A on set A. Second part star is associative on A, right? Star is commutative on A, star is associative on A, and the third part A has no identity element. A has no identity element, right? Very important part. What do you mean by A? A is a set which is an order pair of the Cartesian product natural number by the natural number. So A is an order pair. What order pair? AB star CD. Now very simple. First part in this question we have to prove star is commutative. How can we prove this? Let us see. AB star CD. This is equal to AD plus BC comma BD. This is another order pair. These two are the order pair and the result is also an order pair. Now we have to find CD star AB. CD star AB. We have to find this one, both must be the same. Now here we observe that AD is first and the last. Let us see. AD is first multiply last plus BC second multiply third. And the second element of the order pair is BD. This one, this is the second element of the order pair. The first element of the order pair is what? First multiply last plus second multiply third is the first element of the order pair, and the second element of the order pair is second multiply second. Now by this way we can find CD star AB, that is first multiply last, that is CB plus second multiply third DA and second DB. Is both order pairs same? Yes. Two order pairs are equal only when the first element is equal to the first element and the second element must be equal to the second element. So in this case, AD plus BC is equal to CD plus DA, AD was it, and BD is equal to DB. Both are the same things. So since these two are equal, so therefore we can say that A B star CD is equal to CD star DB. So commutative law applicable. So therefore commutative law is applicable. This now you can write it as AD plus BC comma BD. No problem. Both are the same thing here. Now first part completed, very simple. Second part, to find associativity, we have to consider AB, CD as well as EF belong to the natural number to natural number. Means set A. That lies in set A. Now to find associativity, first we have to find AB star CD whole star EF. And the right hand side we have to find AB star within brackets CD star EF. Both must be equal. Both must be equal, then we can say that associativity is also applicable in this. Let us see how to find. First we have to find AB star CD. Again the same concept that is given in the question. AD plus BC comma BD star EF. Right? Now what is the first element of this order pair? We have to multiply first with last and the second with third. Then add is the first element. So first element can be written as ADF plus BCF plus BDE. This is the first element. We have to multiply here first and last, then second and third. First and last. ADF plus BCF plus BDE. And the second element is second element of both order pair, BDF. BDF. Right? Now we have to find this one, AB. First we have to solve this bracket. It can be written as CF plus DE DF. CF plus D and the second element is DF. Now we have to apply the same concept here. First element multiply the last element, that is ADF, plus second multiply third, that is BCF plus BDE, and then BDF. Is both equal? Yes. The second element BDF is equal to the second element, and ADF plus BCF plus BD, ADF plus BCE, BCF plus BD, both are the same. Both order pairs are equal. Both order pairs are equal, so therefore we can say that AB star CD star EF is equal to AB star CD star EF, right? So therefore associative law is also applicable. Here commutative law is applicable as well as associative law is also applicable. Now third party, A has no identity element. A has no identity element. A has no identity element. So how to find the identity element? To find the identity element, A star E must be equal to A. Let us see A star E. So we have to consider order pair here. AB, let us see an order pair. What do we mean by this element? This is not an order pair. Let us consider this order pair in E1, E2, and that is equal to AB. Right? Now by this binary operation we can write it as AE2 plus BE1 comma BE2 is equal to AB. We have to find the value of E1 and E2. Can we find the value of E1 and E2 by this? Yes. Let us see AE2 plus BE1 is equal to A and B E2 equal to B. So E2 equal to 1 and we can find the value of E1. E1 equal to 1 by B, right? So we cannot find the exact value of E1, so A has no identity element because we cannot find the exact value of E1 and E2. In terms of B and A only, we cannot find the numerical value of E, identity element, both. You can find E1 and E2 in terms of A and B, that is not the identity element. So we cannot find the identity element in this question. Now, the binary operation over. It's very simple topic, binary operation. You can solve the question related to commutative law, associative law, distributive law, identity element and the inverse element. That is all about the binary operation. We'll discuss some more chapter in the next tutorial. Thank you.